My name is Nestor, and now I'm going to present. Well, now we are the team. We are going to present this file. Well, now I'm going to present all the team's members. And first of all, Bernard Chandri, Santiago Muñoz, Ramón Roca, Montse Garbaró, Néstor García, Ainara Fernández, Manuel Jiménez y Gerard Muniesa. And now, my colleague.
So I'm going to introduce you the project we've been working on these past 4 months. So this project was set as a cooperation with ETSAP, Escola Arquitectas, and DCR, an NGO from Senegal that provides services to undeveloped villages. They have a clinic in Mishra, so they can attend people in sites. And as the UPC that are working on the communications between these programs to afford these services that we all know, but they don't, like access to internet, information, and communications to these sites. So this is the main scenario that we've been working on it, and this year has this the central in Mallorca, the clinic in Mishra. We just studied this communications, and also to the tracks where they can afford to these uncovered villages services like access to Wikipedia information and also clinical services like dental care, etc. And now I let my teammates explain how we solve this scenario.
Now, I'm going to explain briefly the requirements and specifications that this project must meet. First of all, is that our project must allow doctors to switch to a digital storage model rather than storing medical records and handwritten forms, which is what they're doing right now. This system must also allow these records to be synchronized between every track and the clinic, and even their headquarters in Mallorca. To do this, we must develop a connection between every track and the clinic in Mishra, and then a connection between Senegal and Mallorca. This system should also have the ability to gather statistics and other aggregated data to understand the current situation of the project. And finally, the trucks, aside from being mobile clinics, should also turn into community centers in a sense, and providing a local network that provides villagers with access to educational resources or other things that they wouldn't have access to. And now, my teammates will continue.
Okay, so following with the design solution, and once we have decided what was our requirements and specifications, we decided to split our project into 2 main products. The first one being Medical Record Manager, MRM, which is a software developed with the aim of solving all the problems related with medical record managing and storage. And the second one being Educational Decentralized Cloud Application, EDSA, which is an infrastructure that aims to offer offline content and resources in an unconnected zones or villages. So, starting with Medical Record Manager, for this product, we needed to solve 3 main needs. That is that the record needs to be in a digital format. They need to be stored digitally and securely in the tracks. And once the track go back to the clinic, they need to be able to synchronize the data between computers. So here you can see an illustration of how does it work, this solution. So there's a graphical user interface where the doctor can input all the data relating to the patient. And once all the data is input, he clicks save, and all the data is automatically saved in a database stored in the same computer that the doctor is using. and this computer is in the track. So once the track goes back to the Visira clinic, there they can synchronize the data between devices. So going a little bit further in the technical overview, here we can see that the digital input is made through a graphical user interface that is with the Python. It's very simplistic and it has only the few options that our client told us that they needed, because one of the client's priority was that it needed to be simple, so we tried to fulfill this wish. And so the doctor is using this graphical interface, and when all the data is inserted, he clicks save, and then automatically all this data is stored in a SQLite database in the same computer. So we choose to use SQLite instead of MySQL or SQL because it's lighter. And when you're working with offline storage, especially if it's for an NGO, that we can assume that they probably don't have the best computers, it's always better to do it lighter. And when the track goes back to the Visira clinic, then they need to synchronize devices. So we build a protocol based in sockets using a strong encryptation because we know it's data form, it's a sensitive data, so they need to be secure. And when the computer in the track and the computer in the clinic are connected to the same network, it doesn't matter if it's internet connected or not. It can work in an offline network that can be Wi-Fi or even just an Ethernet cable. They can connect and synchronize the data between devices. So here you can see a little demonstration of how does it work.
So here is the demo for the MRM program. So we have a very simple and very minimalistic menu. That's because one of the requests from our clients was to have only the few options they really needed to make it simple, so that everyone knows how to use the program without needing information. So the first option that we see is add new patient. As the name indicates, is to add new data point from some patient. So we can input the name, the surname. Those two data points are mandatory. The system requires you to enter both in order to be able to save form. Then we have to view the date. We can navigate over this calendar, find the date that we want to set the birthday. Then we have the gender, the address, phone in case contact is necessary. Then we have the dental chat where the doctor can simply point which teeth are affected by which pathology. The pathology can be selected in this menu. We can, for example, see that there are a few options. They can also write some comments. And finally, they have materials in order to record what materials have been used in this appointment. Finally, they can save the patient record. The second option that we see in the main menu is search information. This is a search engine in order to find the medical record of a specific subject. So we can see that we have the search bar, words like name, and in case you want to read the full record, we can just click this button, and now we can see all the information regarding to this patient. The third option that we see in the main menu is statistics. This is to get and to create aggregated data based on the information contained in the database. It's an SQLite database. So we can see that in charts. Here we can see the number of patients that have been attended first. The second one is the number of units have been used of each type. And finally, we can see a graph that shows us what's the prevalence or how frequently each illness or each pathology has been found in the patients that we have attended. And those graphs can also be saved in a PDF using this button, so they can be exported out of the program. And finally, we see the search user synchronization. This option allows us to do a server patch, which means to upload all the data from the track to the central server PCR cleaning para server pool, which is a download from all the data in the PCR cleaning to our computer track. So here we can see an example of the server pool working. With closely, you can see that the last page is 100. So now we're at the server pool, which means that it downloads the information from the central server. Now we can see that the last patient is overlapping, which means that a new patient record has been added via a server pool, which means that this information was contained in another computer and it has been downloaded to this computer. So this is a demonstration server synchronization. And that's a demonstration of the data record manager program.
Okay,
So here is the demo.
Ya. ¿Quieres repetir? No, ya está.
So here is the demo for the.
Es que no puede ser. Ya está. Ya está.
okay, so regarding the EDSA solution, we have two main needs that we needed to solve. The first one was creating a local network without an internet connection. And the second one was offering resources offline in the same local network. So here again, you can see a little illustration of how does it work. There's a computer, the same computer that the doctor is using. So there's only one computer for each track, where all the offline content is stored. And then using a router, a Wi-Fi network is created, and all the users can just connect to the Wi-Fi and access the resources. And going again, a little bit further in the technical review, how does it work? There's a Wi-Fi network that is created using a router, and in the computer, there's running two main softwares, CHAM and Kiwix. So, using CHAM, what it allows is to create a local network inside the Wi-Fi network. And how does it work? When the user connects to the Wi-Fi, they enter the URL of our web page, and they can enter then the web page using the local network that is run by Sham. And once they are in the web page, they can just scroll and choose what content do they want to access and what videos do they want to watch. A remarkable thing is that the web page is highly editable, so the user can, the user or whoever is using it, can choose what videos they want to offer or what content they want to offer, and it's easily modifiable. So here you can see a demonstration of how does this infrastructure work.
Well, now I'm going to show you the demonstration of the Excel drive. Well, first of all, you need to connect the router to the power supply. Then you need to connect the cable to the router and also to the PC of the computer. Then you need to start the CHAM app, which is those one. I already started. Easy or make faster. And also you need to start the Kiwix, the Kiwix server, which is already on. And then once you have the server, the local access point, you need to connect it to the Wi-Fi, which is 5. And then you need to put the EPU with the name of the web page, which is this one, and then it's ready to change. Well, now we are going to see the Wikipedia link. As you can see, here we have the Wiki dictionary, and if we search the word huevo, it automatically redirects to the word. Well, inside the web page, we have the dental care. And as you can see, you can add photos, you can add some text, you can add some videos.
You can see you can extend them, and they're all completely charged when the page is refreshed. And well, here we have some more examples about it. Here a mock-up.
Well, now,
Okay, right now I'm going to present the business idea of the project. I'm going to explain the value proposition. And first personal title that really summarizes the main idea of our project. That is, be more productive with less paperwork and spread knowledge. Well, and here we explain a little bit that we have created an offline mobile platform for distributed storage that allows to connect the villages as well as the network deployment that you have seen before. And here we have designed our business model canvas, and I'm going to present the main topics of the model canvas. As a revenue stream, we have the paid license and the hardware sales, the customer segments that we want to get involved in our project are the dentists, also the patients, the villagers that can use the offline network, other health professionals, and the donors of the NGO or the business overall. And also, the core structure of the project is the office and equipment, the development of the developers, other human resources, and marketing advertising expenses. And well, we here have also summarized the full value proposition of the project. As I explained before, we use a simple user interface. It's available offline. It's the scale. It's educational and provides connectivity. We pretend to make the product really affordable. And one of the main ideas is that we allow to reduce the time doing paperwork.
All right, I want to summarize the sustainability results. To start, the environmental impact about project development, we make this total footprint. This is 179.27 kilograms of CO2. In the project lifetime, during the application of our product, we estimate the total footprint of 1.6 kilograms of CO2 per day. And this quantity, we thought that it was a lot. So we calculated a system with solar panels that requires us to supply the energy that we need. Battery capacity with 2,250 ampere hour, power of 572.3 watts. About the social impact in the development, we have learned what is work with teammates. Also, we have learned how the engineering project works, and also we have learned the importance that have the search part and the search part of the project is very important. So we learned that. During the lifetime of the project, this will this will make it, this will permit, this will allow the dentist on the clinic make all into the computer, so the reports will the report and the patient and all will store in the database, and it's really more comfortable for the data to work with the data. Also, we will provide knowledge to some countries, because we will bring the possibility to connect to an area with Wi-Fi with an offline mode. And also, this project is also applicable in other parts of the world. It's not just for Senegal. So this is, we consider it's important. And about the risk, the environmental case, if some of the devices that the project needs to work for it work, these devices broke, this generates pollution. Also, if they opt to use the solar panel system, the battery, if they are broke or something like that, it will make a lot of pollution. Also, in the economic part, if no time is some device that the system requires for work, it's broke, the price will increase. In the social part, if when the truck is have not returned to the clinic yet, and the computer broke, and maybe the data that is not synchronized with the clinic, maybe it's lost. So that's the worst case. That's awesome.
Well, now I'm going to do the conclusions. In this site, we have things that we wanted to check. As you can see, digital data input, offline storage, synchronization between devices, Wi-Fi network, local network, and offline resources. As you can see here, we achieved everything that we wanted, so we are really glad. The lessons that we learned, well, of course, we learned to learn Python, SQL editors, and also HTML in the parts of the software, and here on the part of the website, and also to create a local access point. And of course, the things that we learned is the importance of searching information at the beginning, and also the planification. It's really important to planificate the group. And also the future work. Well, this project is scalable and flexible, as well as a robust model, and can be implemented easily by another causes and with few economical resources. As said, Gerard. And the last thing, thanks to the Excel and Hyperlux Mobile, and also the server for trusting us and giving us a chance to do this Solidity project. Thank you.
¿Vamos cansado o dígale des d'allà, que la gent no s'ha posat. Carles, que si vols alguna pregunta.
Carles, vols fer alguna pregunta?
Ja ho veig congelat.
Però, bueno, no sé si ens escolta o no.
Correcte. Sí. Com para tota la presentació.